Good morning, everyone. We'll start in a minute or two. Let other folks join in.
Session we had, you had given
That you need to set up. That here did not
but
resolve.
if you can share the password now, then I can just finish the process.
Password is something that you need to set up. I mean, it's something that you will take care of the password.
Harshit, I remember last session we had, you had given like a set of things, like this is a username for password, port, and everything.
Password? I don't remember I gave password for this. Let me check.
Ah.
The username I gave as Postgres, right?
Yes.
Password. I think I remember I gave the password for this, but do one thing. Open you're on MacBook or Windows?
Windows.
Okay. Go to this command prompt. Go to command prompt and type in this. What I'm saying, sending on the chat. Type in this, and it will ask you to get the password. Put the password there, whatever you want.
Oh, okay. All right.
I think they should have. Password is something that you can decide yourself. It's not something that it would be. Specifically, we will be talking about the different types of joins. Okay. So till now, what you're seeing, like we are making use of one single table to write the query, but that won't be the case every time. So you will need to have, you can have multiple tables to build the query. Now, if you're using multiple tables, then definitely the first step is you may need to join those tables. Now, to join, there are different types of joins that are available. Inner join, left join, right join, self join, outer join. So these are some specific types of join that are there in SQL. And majorly, we use inner join and left join. Okay. But then self join is one such kind of join which is sometimes asked in the interview. And people generally get confused because there is only one table. Now, when you think of join, the first thing that comes to your mind is there would be multiple tables, right? But if you are having a single table, then the question is, what am I joining this with? So I will come to that also in this session, but let's get started with the inner join. Okay, I'm sharing my screen. Okay, is my screen visible? Anyone?
Yes.
Okay. Now let's suppose the two tables. So this is one. This is the first table. You have employee ID, name, department ID, and the manager ID. So the first thing which, as an analyst, you should think is these are like in department ID. There are some records which are null, and there are some people who do not have a manager ID. Okay. The way to read this is, for example, employee ID 2, the name is Bob, the department ID is 2, and the manager ID is 1. So manager ID is 1 means Alice is the manager for Bob. Okay, that's how you generally, in a first glance, you should start understanding the data, like how the data structure looks like. Similarly, for the employee ID 5, I have the employee ID 5 has the name Eve, and this person does not have a department ID. Now you do not go into that thing that how can an employee does not have a department ID and all. There could be a data issue, there could be some other reason. We don't go into that kind of reasoning. But the way to read this is employee ID 5 has the name Eve and the department ID is null. Okay. Now there is another table. There is another table called as departments. So this table is pretty simple. There's just department ID and the department name. Okay. Now let's suppose I want what I want is I want for every employee I should have a department name. For every employee name, I should have a department name wherever there is a match. Okay. If someone does not have a department ID, they won't have a department name also. That is totally fine. Okay. Now, we write this down. department table has your department ID and department name, whereas your employees table has EMP ID, that's the employee ID, then it has the EMP name, then it has the department ID, and then it has the manager ID. What I want is output should have your EMP name and the DPT name. These two columns only, wherever there is a match. Now, first thing that you will notice when you look at both these two columns, columns in both these two tables is department ID is the one which is a common column. Okay. Now, whenever you are joining, there has to be a common column. Now, common column does not mean that the name should be same. No, that is not the criteria. The name could be different. But if you are joining, they should have the same data type, or else you need to change the data types, and they should have the similar value, or else you won't get any row in the output. Okay. Now, this question could be solved using an inner join. Why? Because what I need is I need the common values of, like, I need the employee name and the department name, which are in two different tables. And the question is, I need only those departments which are present in both the tables, in the employee table as well as in the department table. Now, to write an inner join, what I'll do is select e.emp name, comma. The second table that I need is department. So d.dpt name from employee E join departments D on. So I'm joining these two tables, employees E and department D. E and D are just the aliasing. I'm doing this just so that I do not need to write employee.emp name and departments.dpt name. That will be too big to write. Moreover, I need to use alias because if you see this DPT ID, this column is present in both the tables. So if I do not use alias and I try pulling in DPT ID, it will get confused from which table it has to pull. It has to pull from the employee table, or it has to pull from the department table. So it's always a good practice to use table aliasing, like E and D I have done. So I'm joining these two tables. Now the next thing that I need to do is I need to give a joining condition. The joining condition is the department ID should be same. So wherever the department ID should be same, I'll get an output. What I'm saying is on specifies the joining condition. So joining condition is department ID should be same. What I'll do is I'll run this and see what is the output. So Alice is part of HR, Bob and Charlie, they both are part of engineering, and David is part of sales. Now, this is an inner join. Okay. I could even write, I have written only join here. Join, if you write just join, it by default means an inner join. But if you want to be very clear, you can write inner join, and this is also perfect. Okay. Now, the concept of inner join is it joins two tables on a column or on a group of columns and returns only those values which are common in both the tables. So common in both the tables in the terms of the column that you specified. I specified department ID. So wherever the value of department ID is same in both the tables, it will return those values. The concept of inner join is it returns only the common values between the two tables. Okay. It won't match the null values. Null is actually not a value. Do not confuse null with zeros. Okay. So example, if you see this one, select start from employees. Okay. It has one value as department. Now question for you here on this question. So select start from employees, and this is your department ID is null over here. Let's suppose in my department table also, suppose there is another column, another value department ID. Okay. Fifth row, and that value is null, and let's suppose the department name is finance. There is one value in employee table which has the department ID is null. In department also there is one value with null. Do you think it will match? I'll explain this once more. Okay. So okay, is everyone there? Yeah. Okay. So there's in department table, let me just download this data for you. Let me just put this in this. Give me a minute, guys. I'll just paste this into it so that will be easier for you. So this is my department table, and herein I have one value which is null, and the name is
Screen
finance.
is not visible.
Ashik, your screen is not visible.
Okay, now is it fine?
Yes. No, not yet.
Yeah, okay.
Is it visible or not?
Yes, yes.
Yes.
Okay, so this is my department table. Okay, so this has one value which is null now. Okay, this is finance, and let me run this one also. Mm. Okay, and this is my employees table. Here also there's one record which is null. Now when I'm joining these two, what do you think will happen to these two records? Will it join? Will it not join? Because this is also null. This is also null. What do you think will happen? Will they join? I'll explain this much more. See, this department is actually joining with this one. Okay, these two is joining with this because the department IDs are same. This one is joining with the sales. Okay. The now question is, will this null join with this null? Because they both are null. Is it something that is possible? Okay. So these two won't join. The reason is null is not a number. Null is not a string. Null does not mean anything. It does not represent anything. It's not zero. Okay. So then even if these two are null, it won't join. Okay. So do not confuse this with nulls. Null will join with null. That won't happen. Similarly, this 5 won't be able to join with anything because in department table, there is no department ID with a value 5. Clear? So these two, so this one will also not join. So ultimately, the number of record that I'll have is these 4. So the way it will showcase is EMP name and the DPT name. Okay. So the first one, Alice, it is joining with department ID 1. So this will be HR. Bob and Charlie, here, they would be joining with department ID 2, and they both will have that value as engineering. David has the department ID 3, and the name of department ID 3 is sales. So this will be the value. So this will be your output. These two would be left outside because there is no department ID which is there in the department table for these two employees. Clear? Any doubt?
Yeah, I just need to confirm if there is one more column in the first table, which is for the department. What will be the output then?
Department is in the sense?
Like we have department 1, 2, 3, 4, HR, engineering, sales, marketing. And then if we have another one column here in this table.
Okay. Let's suppose there is another column called as location. Okay. Now, let's suppose the values is Bangalore, Chennai, Hyderabad, Delhi. Okay. And this one is Kolkata. Now, the output will depend on what columns you are pulling in the select statement. As of now, if you see this one, I am pulling only these two columns, EMP name and DEPT name. Okay. Now, suppose I change this a bit and I start pulling in the location also. Okay. I want another column, which is the location. So Alice has a department ID 1. It joined with this. Location is Bangalore. It will populate Bangalore. Bob has a department ID 2. 2 is engineering, so and it is in Chennai, so it populated Chennai. 3, Charlie is in department ID 2. Same thing, location is still Chennai, so it will populate Chennai. David has the department ID 3. Department name is sales. Location is Hyderabad. This will be your output. So it depends on what column you're pulling in the select statement. Based on that, it will show you the output. Clear? Any doubt?
Can you explain again the statement thing, like in the Postgre?
Really?
This is all clear. I just wanted to go through the statement, like what query did you?
Okay.
type?
What I've written is, I've first of all selected the column that I need with the aliasing. Aliasing is actually an important thing because many times you will have the same column names in the joining tables. So aliasing helps you identify from which table you have to pull the column. Okay. So E and D are the aliases. From employee E, join department D. So I'm joining these two tables. Okay. You're joining, that is fine. But on which conditions you're joining, that is specified using the on. So I'm joining and saying that join only in those cases wherein the department ID columns match. Okay, wherever the department IDs are same, you match that and join. Okay. Clear?
Yeah, Harshit, you have used E as alias for employee name, and
As,
in employees also you have used E. So
no, E as the alias for the employees table, not for the column name. Okay. So here what it's trying to say is this part. It says from the employees table, pull in the employee name column. From the employees table, pull in the employee name column. So aliasing is done here for the table name. And this is specified over here. Employees E. Employees mean E is the alias for the employees table. Clear? So E.emp name, I could even write, I don't want to use aliasing, so I will write employee dot employee name. I could write this as departments dot dbd name. This is also fine. But the problem in writing this is every spelling. Okay, I'm using this. So change everywhere. Hold on. Okay. So this is also fine, but the problem is many times you will end up pulling in 7-8 columns in your select statement. That time writing big column, a big table name is difficult. Like every time I start writing employees for every column name, that is difficult. Okay. So to overcome all that, we start using aliases, wherein in our case, for the employees table, I have used E as the aliasing, and department core table, I have used D as the aliasing. Okay. Now, this was simple because this is an inner join, and the simple thing is I just bring in the common values from the two tables. Now, there is another type of join which we call as left join. Okay. Now, suppose I have again these two tables. Okay. Now, the thing is, here I lost out on 2 employees. Okay. I could not get any information about these two. I had information only for Alice, Bob, Charlie, and David. For 5 and 6, even Frank, I could not get any value, any record. Okay. Now, to overcome all that, I came up with the left join. What left join says is, by default, all the values of the left table will be part of the output, irrespective of whether I am able to join them with the department table or not. Earlier, in inner join, I could only get the common values. But in left join, I will get all the records of the left table, irrespective of whether the joining takes place or not. Okay. Now, what is left table then? The question is, what is left table? So let me write this down. Let me show you the query, and I'll explain it to you how what is actually the left table. So what I'll do is, I need all the values of the left table. Okay. So what I'll do, select e.emp name from a d.dpt name from employees e left join departments d on e.dptid is equal to d.dptid. Now, before I run this, just see the output of this one. How many people you have? Only 4. Okay. Now I'm running the left join query. Now see the difference. Okay. How many records I have? 6. Now left join means I set all the values to left table. Whatever is written on the left side of this left join is your left table. What is there on the left side? Employees table. Employees table had 6 values, 6 names. All the 6 are getting populated, irrespective of whether they are able to join with their department table or not. So Alice, Bob, Charlie, and David, they were able to join and they got their department name. Eve and Frank were not able to join. Why they are not able to join? Now see the values for that. For Eve, department ID is null. Null, I said you won't be able to join any null value. So by default, this will be null. Okay. Frank has the department ID 5, but your department table does not have any value as 5. So this will also, department name will also show up as null. But they will be part of the output because you are doing a left join. The main logic of left join is all the values of left table, irrespective of whether you are able to join or not, will be part of the output. The easy way to populate the output, if you're doing it manually, is to do one thing. Whatever columns you are pulling in from the left table, take it as it is. Just copy paste this. Because as I said, whatever the values are there in the left table, they will be part of the output. So these all came in. Now see what is there in the right table. Department ID 1. Okay, this is HR. Fine. Bob and Charlie, they both are 2. So they both are engineering. David is 3. 3 is sales. Okay. Eve and Frank won't be able to join because, as I said, Eve is having null department ID. You cannot join null values. Frank has a department ID as 5, but department table does not have any value as 5. Okay. So this is the way you actually run the left join. The only difference in the query that you will see is instead of inner join, you use left join. So while solving left join problem, one thing you need to keep in mind is what the question is asking. The question asking for like all the record from one particular table. If it is true, that particular table has to be in the left side for left join to perform. Everything else, if you see it from a query writing perspective, remain the same. Clear?
Like, can we take like for inner join, all the missing values will be ignored? Can we take like that?
Yes. If the joining is not successful, all the values if you're using inner join, all the unjoined values will be ignored.
Okay, thank you.
Actually, you know what? I could even convert this into a left join to an inner join, but I'll take that up later. Let me give you a brief. Okay. So this is the left join. Okay. Now suppose I put a filter where department name is not null. Now see this. It's similar to inner join. Okay, that actually becomes one of the questions, but I could even, if someone is asking you to find out the common employee name in the department name, the easiest way is to do this. But if you don't want to use this, you can even do this. So what will happen is, in the first case, you are getting all the values from the left table. Department table is coming as null for 2 records. That is because the joining is not successful. But when I put this filter, where clause, department is not null, it just converts exactly the same way as the inner join. I'm not going into the detail of this because otherwise you will get confused. Okay. Any doubt here? Okay, so I'm not seeing your questions if you're posting. Pause here for a minute because these two are the most important joins that you will work in SQL. Let me know if you guys have any doubt. The query was, it's looks like this. Ignore this part. I mean, okay. Moving ahead. The next join is the right join. Very rarely used, and you will understand the reason why it is very rarely used when we start writing the query. To understand the right join, let's assume the question is, so first in the left join, the question was, I need to have all the values from the employees table, irrespective of whether they are able to join or not. Now in the right join, let's assume the question is, I need to have all the values from the department table, irrespective of whether the joining is happening or not. I want to have all the values from the department table, irrespective of whether the joining is successful or not. Okay. Now, left join, right join, I mean, they both are written almost the same way. I'll copy this and I'll put it over here. The only thing that I will do is right join. Now, what right join says is all the values which are there in the right table, they should be part of the output. That means what is in the right side? Department. If this is the word, this is your department is the table which is on the right side. Now, when you run this, now see, irrespective of whether you will notice the difference from here. Wait. Now see this, there were all the 6 values are there in the left table. So all of them are populated. Here you will get, I think, 5. Okay. Marketing, why marketing is coming up? That is because if you see these two tables, marketing has a department ID 4, but there is no person with a department ID 4 here, but it is still part of the output because I'm doing a right join. Okay, so all the values of the department table are by default populated. Do not take this one because this is not there in our data set. Okay, so I made this up later. So all the values which are there on the right side, that is the department table, they are populated, they are there in the output. So we have department 4 also part of the output, although no employee is tagged to department ID 4. If you see this, there's no employee tagged to department ID 4. Now, the thing is, this is actually not so much used because I can easily convert a right join to a left join and do the work. For example, I could even write it like this. Okay, and this will give me exactly the same output. Okay, the only thing is whatever was there on the left, I made it right, and whatever was there on the right, I made it left, and I changed the tables, employees to department and department to employees, and I think everything is done. Okay, so that is the main reason why we're not using right join as such, because we convert everything to right join to left join and then change the direction of the table. Okay, so in right join, whatever the value on the right table will be part of the output by default, irrespective of whether we are able to join them or not. Is it clear? Any doubt?
Nope.
Anyone else? Let's see the chat. Okay. Now this is fine because this is left, right, inner, and that's fine. But there is one more join, that is your outer join. Okay. Now what outer join says is, so till now what is happening is the inner join will give you the matching values, okay, only the matching values. Left join will give you all the values from the left table. Right join will give you all the values from the right table. But there's another type of join called as outer join, which gives all the values from both the tables, irrespective of whether the join is successful or not. Till now, you are actually targeting the common values, left table values, right table values, and then that's it. Okay. But now this outer join will give you all the values, irrespective of whether the join has taken place or not. So just change right outer join. So what will happen is okay. Now, outer join means, let me take this output as the EMP name and your DPT name. Okay. Alice, this person has the department ID 1 and this is joining with HR. Bob is joining with the department ID, has department ID 2 and it will join with this one. So department name is engineering. Charlie has department ID 2, which has the name engineering. David has department ID 3 and has the name sales. Eve will not join with anything, so this will be null. Frank has the department ID 5, but 5 is not present over here, so this value will be null. Now coming to department table, because I said it will pull all the values from both the table. So what is left here? Only one value is left, which is not matched. That is your marketing. Okay, so it will put marketing over here, and this will be null because there is no employee tagged to the department name marketing. So full outer join means it will pull in all the value from both the tables, irrespective of whether the join has taken place or not. If the join has taken place, it will populate the table, it will populate the columns, or else it will keep it as null. Inner join will give you only the matching values from both the table. Left join will give you all the values from the left table. Right join will give you all the values from the right table. And full outer join will give you all the values from both the tables. Give me a minute, I'll be back. Give me a minute. Okay. So this is how a full outer join works if you're doing it manually. From a query perspective, you just need to write full outer join over here. And it will give you it will give you the values from both the tables, employee table as well as the department table. So for example, if you see this, Eve and Frank, they both are null because Eve has null department ID. And I think there's some issue with Frank also. Yeah, Frank has department ID 5, which is not there in the department. So that is also null. And marketing is getting populated as it with no employee name because there's no employee tag to marketing.
Is this kind of using right and left both?
Together, correct. It's a combination of right and left both together. Left join is pulling in all the left values, right join is pulling in all the right values, just combine it. Kind of that.
Hi, you have written here full left. So is there any partial version of outer join?
No. Don't go into the wording. There's no partial outer join. Partial outer join will actually result. First of all, there's nothing called as partial outer join, but you can. Vaguely you can assume partial outer join will be a left join or a right join. But please do not confuse because if you are interviewing somewhere, then the interviewer will get confused. Don't use that word of partial outer join. But good for your understanding.
Yeah, got it. And also, can we join multiple tables with the same, common column?
Multiple table with the
common column, like here we have joined with department ID. So if another table have department ID, can we join the third table with these two tables?
Yes, we would go through that example also. Just give me some time. I'll go through that example also.
Okay, got it. Thank you.
Thank you. Anyone else? Any question?
Can you please share these examples in the chat for reference so that we can save it?
Yeah, give me, like, there are 2 more types of join. I want to cover that, then I will send this whole thing to you on chat.
Okay.
I want to cover 2 more kind of joins before I do that. Anyone else? Any question? Data from CSV start. Okay, Nishant, I'll cover your question also, but you need to give me some time. Okay, I'll cover this in this next session only, but you need to give me some time. Okay, coming to next type of join, which is called as cross join. Okay. Now what I want is, I mean, I'm fed up with trying up, like making joins, like looking at this department and then department ID and then matching the department ID. What I want is, I want every employee to be tagged to every department. Alice will work for HR, engineering, sales, marketing, finance. Bob will also work for all these 5 departments. Charlie will also work with all these 5 departments. Okay, so I want to try something like that. For that, in short, what I'm trying to say is there is no joining condition only. I'm not checking the department IDs only. Whatever department ID you're getting in employee table, just match it with all the department IDs in the department table. I don't want to look into whether joining is successful or not. I'll make all the combinations, whatever is possible. To do that, what I'll do, select e.emp name, comma d.dpt name from employees E cross join department T, done. And when I said I want to join each employee with each department, that means I'm not giving any condition only. So there's no condition over here now in cross join. Make all the combinations which are possible. Sorry. Okay, see, it has placed Alice, Bob, Charlie, David, E, Frank in all the departments. Okay, so the first thing to notice here is in cross join there is no joining condition. In all other join there would be joining condition, but in cross join there is no joining condition because you're joining each row with every other row in the second table. Okay, now there's one question. If
So
you
will it just throw like the information randomly, like it is saying the department name for Alice's HR?
No, that's what I was going to. Hold on. So what it will do is it will join Alice with these 4. It is not looking at, there is no joining condition only. So it will join Alice with these 4, Bob again with these 4, Charlie also with these 4. So all the employees with all the departments. There's no joining condition.
Okay.
It's a cross. Now one question which sometimes few of the interviewers ask, in one table, first table, you have 5 records. Second table has 10 records. And if I do a left join, if I do a left join, how many records I'll get? So if I do a cross join, how many records I'll get? 50. Correct. So that's the right number. But now you guys need to go back whenever you are free over the weekend. Just think about 2 more problems, okay? And it's actually asked during the interview. I want to know the minimum and the maximum number of records in inner join and in a left join. If suppose the one table has m records, m number of records, second table has n number of records. Okay, so I want to know what is the minimum and the maximum number of records that are possible in an inner join and a left join. Think over it after the session, okay, over the weekend, because this is not something which is straightforward. You guys are
It's like
starting.
a function, right?
Yeah, m is any number you can assume. N is any number you can assume. Okay.
You know, like the function mapping we used in linear algebra. It's like
No,
that.
you don't need to go into that details.
Okay.
Just think of some random number, like let's suppose first table has 10 records, second table has 3 records. What do you think would be the minimum and the maximum number of records that are possible in an inner join and a left join? So there is no linear algebra, just m and n is just random number, nothing more than that.
I guess minimum will be 0 and maximum is the left table rows.
Minimum of m or n would be inner join, and left join would be m, or if table 1 is kept as primary left table.
Think deeply, not straightforward. Your one thing would be correct. I think. Okay,
If there is no common, then 0.
Correct. So that is the easier one. If there is no common, then there is 0. Okay. But what about others?
Maximum, for maximum, it should only get all the rows from the left table if we want to get the maximum?
No,
No. Okay.
not at all true. Okay, that's something. It's not straightforward. Easier, like the easier one you have answered correctly. The easier one you have answered correctly, that it will be 0 in a case of inner join. Okay, if there is no matching value, then it will be 0 for a inner join. But what about left join? Okay, that's something. Just go back, think about it, and we'll discuss. But this is one important question for the interviews. Going back, let's see. Okay, let me know if there is any doubt, or else I'll go to self join, which is a bit difficult to understand sometimes. Let me know if there's any doubt, or else we'll start with a self join. Okay. Moving on to the last type of join, which is called as self join. And for this, let me open the Excel. Okay, let me take up this one. In self join, you will have only one table. Okay. Now the question is, when there is a self join, then how can I have only one table? There has to be multiple tables, or else where is the concept of joining? Now, a self join means the table will join with itself. Okay, table will join with itself means, from your understanding point of view, you can assume there are two tables which are exactly same. Okay. Now, suppose for a self join, the question is, you need to find out the employee name and their manager name. You need to find out the employee name and the manager name. Nothing to remember here is, see, a manager is also an employee. Okay. So manager entry should also be there as an employee. For example, let's take this one. This is employee ID 2, name is Bob. Manager ID is 1. Okay. Now the manager ID is 1 means, what will the name of manager ID 1? That will be Alice, because this person has an employee ID 1. Similarly, employee ID 3, the name is Charlie. Manager ID is 1. That means Alice is the manager for Charlie as well. Coming to David, employee ID is 4. Manager ID is 2. 2 is Bob, because for Bob, the employee ID is 2. What I'm trying to do is, I'm trying to equate the manager ID with the employee ID. Now to do this, what I do, for your understanding, this is not something which happens in the query, okay? This is the one table that was given to you. You created a duplicate for it. Let's assume this is the employee table, and this is your manager table. Now the logic here would be, this manager ID would be equated to this, and I need to pull in the employee name and the employee name from here and the employee name from here, because a manager is also an employee. If I talk about this one, this is manager ID 2. This manager ID 2 should be equated to this to get the employee name and the manager name. Okay. Now how to write this? To do this, let me go back to this one. So what I do is select e.emp name. Now the thing is, one thing I forgot. See, employee name and employee name, they both are same. Okay. How will the end user identify which one is employee name and which one is the manager name? To do that, I'll do a bit of aliasing. This one is equated to this one because this is the manager ID, and from here I'm pulling the manager name. Okay. From employee table, I'm pulling the employee name, and from this table, I'm pulling the manager name. So what I'll do, e.emp name as employee name, comma m.emp name as manager name. From employee E join manager, join employee M. Okay, both the tables are same. This is self join. Only the aliasing is changing. Just because of aliasing, it will assume there are two different tables. Okay, it will assume there are two different tables. One with the aliasing E, another one with the aliasing M. Okay, so based on this, it will be trying to pull in the employee name and the manager name. Employee employee M on. As I said here, you are joining from the employee table. You are pulling in the manager ID and joining with the EMP table. Joining with the EMP ID from the manager table. Okay. So what I'll do is on E dot manager ID is equal to M dot EMP. So I'm not written self join and all here. Okay. There's no word called a self join here. Okay. It will, you have to write you have to write a join only. Self join is a concept. Do not confuse it with the keyword. Employees. Employees is a table in here. Okay. So what I've done here is, for your understanding, this was the one table that was given to you as question. You assumed there are two tables. Okay. In your one table, you are getting only the manager ID. You are not getting the manager name. But manager is also an employee. Okay. So this is manager ID. You assume there's another table called as manager. You join this manager ID with the employee ID and got the manager name from here. Okay. And this is how a self-join works. This is a place where people get confused because they actually are not able to identify what is the second table. Is it clear? So there's nothing called a self-join. You cannot write it like this. Okay? And then, I mean, this is not correct. So this self-join is just a concept. Okay. Do not confuse it with how you are writing inner join, left join, right join. Those things are different. So whenever there is a self-join question, you need to remember, like, see, first thing, every information is there in one particular table. We don't need to worry about second table. The second thing is you need to create a relationship. How, and most of the questions you will see, it would be like this only, employee and the manager relationship. Okay.
Here also it leaves out null values, right?
Yeah, it will leave out the null values.
Okay, thank you.
Null values will always be left out. Do not worry about that. So it will always be left out.
Got it.
Until unless you are not using a full auto join.
Yeah, that will count.
So as I said earlier, most of the questions you will see would be around usage of inner join and left join. Self join is also there because it's sometimes tricky to understand. You need to think a bit deeply about how you are joining, and most of the time what we see, candidate gets confused. They don't identify, like they start thinking where's the other table. Yeah. Okay. What I'll do, I'll post all this thing on the chat for your reference. Okay. Cross join, Apurva, is something which okay. Let me give you an example of this cross join. So cross join. Let's do one thing. Okay. Okay. But suppose what you have is something like this. You have a you're working on a sales data and you have suppose Flipkart, Amazon kind of data tables, wherein you have one table is, let's suppose, your product table, okay? And you have, let's suppose color, okay? You have shirts, okay? And this is, let's suppose, any color, red, blue. Then you have another table called as sizes, okay? Size could be anything, right? Small, medium, large, anything, okay? So what you want is, you want all the combinations of products, colors, and the sizes. So what you will do, you will do a cross join, and this will result in something like this: shirt, red, small, okay? Now what I'll do, I'll just copy this, and it will have medium, and it will have large. Then you have this one is blue, and this one is blue. So you want all the combinations, okay? This will be medium, this will be medium, this will be medium, and lastly, hold on, sorry, small, medium, and large. Sorry. Okay, so these are the combinations that you will get for every shirt, for every color, for every size, because these are something which will be available in all the sizes. Clear? Okay, now let's increase the level effect. Okay, I'm going to, till now you're joining only 2 tables. Okay, now what I'll do, I'll join more than 2 tables. I'll join, I think, let's suppose 3 tables. Okay. So I have different table names now. So customers new is one table. The same thing, okay, customer ID and the customer name. So you have only customer ID and customer name, okay? Then you have another thing called as, okay, let me do one thing. Let me copy this somewhere. Then you have another, where is this coming from? Hold on, guys. Then you have another table called as product table. You have the product ID, product name, and the pricing. I'll copy this also. And then lastly, I have product ID, you have product name, and then lastly you have price. Okay. Then last table that I have is orders name. Okay, you have the order ID, customer who placed that order, what product it's placed, and the quantity. So this is our third table. Okay. Now suppose the question is, you need to showcase the customer name, which is here, product name, which is over here, and the total price. So total price is your total price is quantity you have, and then where is pricing? Okay, pricing is here. Fine. Let me write the column name also, or else it will get confusing. I have the product ID, product name, and price. Product ID, product name, and price. And the last table is this one, which is our orders table, and this has order ID, customer ID. Order ID, customer ID, customer ID, product ID, and quantity. Product ID and quantity. product ID and quantity. Okay. Now, what I need is I need the customer name, which is over here. Okay. Then I need the product name. Product name is over here. And I need the total price. So total price is nothing but this price into the quantity. Okay. That is the total price. Now, how do you think I should approach this problem? Have to join all the three tables. Without that, though, is not possible. But
First,
yeah.
we should get the customer ID from customer table, and corresponding to that customer ID, we should join on the order table. So
On the
and
order
from-
table, the customer ID, good. Then
yeah, then from orders table, we should get the product ID, and from that product ID, we should search for the product ID on the products table and the
Good.
price.
good. So the approach to join multiple table is you need to identify. So it's not like all the three will be joined in one go. No, that is not something which we will do. The thing is you need to understand which column from which table has to join from which other table from the which other column from that table. Okay. So for example, in our case, what we can do is this customer table. First of all, I'll join with this orders table on the customer ID column. Okay. Because customer ID are the same common column. Okay. So first of all, let me do that. What I'll do, I'll pull everything so that you guys are able to understand how the column identification and calculations are happening. So let's start from orders O, join orders new. Okay. Join customers new C on C dot customer ID equal to O dot customer ID. Okay. Joined only two table till now. Okay, I'm not joining the third one yet. Okay, so this is what I get. Fine. Now what I need is I want to join the third table. The third table is my product table. Okay, so I'll join that also. So how to join? After you have written the joining condition for joining the first two, I'll join the third table. Customer C, products new on. How I have to join? The joining condition should be product table is here. So product ID, this product ID, sorry, yeah. This product ID is here, and this order table also has a product ID, so they both should join. So join products new on P dot product ID is equal to O dot product. So I have joined all the three tables. Okay, I'm not selected the right column yet, but I'm joined the three tables. Now what I need the customer name, product name, quantity, and the total price. So what I do? Customer name is coming from my customer table, so I'll do C dot customer name. Okay. Product name is coming from the product table, so I'll do P dot product name. Then quantity is coming from which table? Quantity is coming from orders table. Okay, this column. O dot quantity. Okay, and then you have total price. So total price, as I said, is the quantity into the pricing. So O dot quantity into P dot pricing. This is my total price. So I've given an alias as total price. Now when I run this, I should get the required columns. Okay.
So join here used is inner join, no?
No, everything is inner join, but I just need the common values because the question is, the thing is like if there is any customer, for example, if I go back to this one and then I let's suppose this fourth customer, Pooja. Okay, so this customer has not placed any order. So what will be the total price for that? Nothing, because this customer has not placed any order. Okay. So the thing is, like, you need to understand from the problem that is given, like what kind of join you need, and more you practice, it will become very easy for you to identify which kind of join you will need. Still, if you get confused, do a manual run. Manually try to understand what kind of output you will be getting if you do inner join, left join, right join. Okay. But in this case, I need only the total, like I need a customer name, product name. So the customer has not placed any order. So I won't get any product name for that. So what's the use of including that person in the output? Okay, so that's why all are inner join here. I've written join. As I said, you can go back and write inner join also. That is also fine. All three. This is also fine. We'll give it the same output. Let me know if there is any doubt till here. If not, we'll start solving some questions.
Hey, sorry, I missed this. Why are we using the brackets here?
This one?
Yes.
Yeah, because total price is not actually given to you straightforward. Okay, so it's not
Okay. Okay.
given.
We derived it. Okay.
So we'll multiply price and quantity to give us the total price. That's why we used.
Okay. Okay.
Any more questions?
Anuja has posted in chat.
Okay. Yeah, I would. I'll go through that as well. Q and non-Q. Hold on for that. But any doubt till here? Okay.
Okay. So is it possible to use like in some scenario, would we be required to use the total price anywhere in the?
Yeah. The total price you're saying, is it like important to calculate or use case to solve calculate?
Yes.
Use case. Okay. What if I ask you what is the total amount paid by every customer? Let's suppose now this is a question
Right.
for you.
Okay.
Now let's try this question. Okay. And Anuj, I'll answer your query. Okay. Meanwhile, as I'm posting this thing in the chat, the question here is, I want guys to modify this query and find out the price paid by every customer. Okay. For Amit, the total price is 50,000 plus 40,000, that is 90,000. And for Neha, the total price is 30,000. Okay. So I want you guys to find out the total price paid by every customer. Fine.
Right.
Anuj, for you, equi-join is nothing but you are equating the two columns for joining. In all our cases till now, from the starting, we have been using equi-join only. Like in this case, we are equating two columns. Here also, we are equating two columns. Okay, so this is all this, whatever you try today is all equi-join. Okay, now let me give you a non-equi, because non-equi means in simple term, whatever is there apart from equal to sign is non-equative, is non-equi. That means something like not equal to, between operator. For example, let me see if I have a table for this. Customer ID this. Okay, fine. Let's take this example. This is the employee table. Let's take this one. This is the employee table and this is the department table. Now I want you to join both these two tables and get me employee name and department name, wherein the department IDs are not same. That means this department ID will not join with this. It will join with this one, will join with these 2, 3, 4. This 2 will join with 1, 3, and 4. Okay. So this is kind of an equivalent, but how to write this? Simple way, whatever you have written till now. So I'll join this, take this, and I'll do a not equal to. Now see this. Let's take an example of one particular employee, order by EMP name. Okay. So Alice is joining with engineering, marketing, and sales. Why? With only engineering, marketing, and sales? Because Alice, the department ID is 1. So I said the department ID should not be same. So it is joining with 2, 3, 4, which is engineering, marketing, and sales. Okay. So this is kind of a non-equi join. I'm not trying to equate the values. I'm trying to check wherever the values are different, then only you join. Okay. The way to write is not equal. Try the one which I gave on chat.
Okay. Thank you.
Thank you. So Apurva, there is a mistake in your group by statement. Okay. There's a mistake in your group by statement. Please check that. Yeah. Meanwhile, I'll just open other questions for you guys. For this, try that for other question. Jagir.
Would we be using sum on total price,
Correct.
and rest of the joins would remain same?
Correct. Everything joins will remain the same. You need to use some, but then you need to make a proper use of group by also. Apurva, it is still incorrect. You have put in incorrect statement in group by.
So group by would happen on customer name then?
See, the rule of group by is, I think I told you in the previous session, that whatever unaggregated column are there in the select statement, that should be part of your group by. Okay.
Okay.
So whatever unaggregated columns are there in the select statement, that would be part of your group by.
Mhm.
Okay. So I'll do this. So I think I got this from you. The thing is, you have pulled in the right columns. Everything is going fine. The only problem is this one. Okay. Whatever the unaggregated. So these are the unaggregated values. We'll use this. You cannot have spaces in column names. Okay. Hold on. Okay, these are different products. Okay, what I need is I need only the customer name, the total price. I do not need this thing. So it will just give me product name, customer name, sorry. Okay. So this is the right approach for this one. Okay. Now let's go back to solving other questions. Sorry. It's this one. Give me a minute, guys. Okay. Okay, let's try this one. Okay. I'm posting the link in the chat. Try this one. The customers who never order. So you have a customer table and you have an orders table. So you need to find out those customers who have never ordered. So for example, in the customer table, you have 4 customers, 1, 2, 3, 4. But in orders table, you have only 2 customers, 3 and 1. So that means 2 and 4 have never ordered. I need the names for those customers who have never ordered. Try this one. First one, never order. So try to find out. You will need to join those 2 tables, customers and the orders table, and then see where the order, where the IDs are null. Okay. Well, looks good. Others? Right. Um, Let me discuss. I think everyone is fine. Okay. Let's see. What's the right approach? This one I got. So, as output. The name is Henry and Max. I think the only thing is missing is this one as customer. So because they in the output they're expecting the column name to be customers. Otherwise, the code is ready. It's fine. Okay. I think everyone got the right answer. Good. See second one. The rising temperature. So we need to write a SQL. Okay, let me post it on chat. Okay. So you need to write a SQL query to find the dates, find all dates ID where the higher temperature compared to the previous date. Okay, and then there is a single table. Okay, so there's a single table. You need to find out those dates which have higher temperature compared to the previous date. There's a single table. So there are actually two conditions. The first condition is your dates, because if they are consecutive dates, then the difference between the dates would be 1. The second thing is the temperature should be higher. So today's temperature is greater than the yesterday's temperature. So this could be solved using the self-join approach. Because it is single table. Okay? Anyway. Good. Okay. So from good. Looks fine to me. This good. Let's see what's the right approach for this one. So it's just a simple case of a self join. So you're joining the table with itself and you're pulling in the IDs. Okay. And the reason and the thing is you need to the questions here write a SQL query to find all dates ID with higher temperature compared to previous date yesterday. So if it's a yesterday, that means the difference between the ID should be 1. Okay. And X and the temperature should be greater. Okay. So if suppose today is 21st and 21st should be joined with 20th, but the temperature on 21st would be greater than the temperature on 20th. That's how it is written. Okay, so this is one. You can work on IDs. The other approach is you can work on the dates difference. So you're selecting ID from the table where the date diff of 2 dates is equal to 1. That means the difference between the dates is 1, and the temperature in the first table is greater than the temperature that is coming from the second one. Run this, I think this should be fine. Okay, it's not there. Okay, this is Postgres, fine. Okay, this one work like this. Hold on. Recorded and this looks fine to me. This is w1 dot record date. Then the same. Mhm. Mm. W1 is go to the previous states. Mhm. This is W1 dot record date minus W2 dot record date equal to 1. Okay, hold on. Okay. I got it. What you're trying to do. Fine. So you are actually what you're trying to do is you are actually doing a cross join here. Who was it actually? So there's a cross join that is happening. That's why it is not picking up. So, but even from a cross join perspective, okay. Only if you do a right cross join. Dot record date minus W2 dot record date. Okay. Okay, there's some issue here. I mean, it's not able to identify the dates actually. So it's not returning the right. Ideally, this should have worked. This one. Okay, I'm doing a join. Mhm. I'll get this checked. I mean, there's something happening. It's not identifying this as date, I think, but I'll get this checked. Okay. All right, we'll pause for today for now. Okay, and in the next session, we would be going through case statements, union, and the subqueries. Okay. Case statement is something which will help you create new columns in the existing table. Union alls, and then your subquery. Okay, and one important thing to if you're trying to solve some complex question, knowledge of subquery or CT is something which is very much important. Okay, I'll start the polls. Meanwhile, if anyone has any question, you can.
Harshit, I
Yeah.
need your help in regarding the installation. I wasn't able to do that in last class as well.
Which one?
The installation of Postgre.
Okay.
Yeah.
Can you start sharing your screen? I'll just see that and
Yes.